Hello everyone, welcome to Team 16 demo of Homework 3 for CSCI599 course. So the objective of this assignment of this Homework 3 was to evaluate the content detection and analysis performed in the first two assignments. So for this purpose, the content extracted from the previous assignment was used, and in addition to that, we also used the metadata stored in the Solar and then tried to evaluate the the data which the data as well as the metadata. So we developed few visualizations as per the task given to us. So let me just show you the first visualization. The first visualization is the classification path is for the classification path from the request to the content. So we use the sunburst D3 visualization for this. So the innermost layer shows us the different request request statuses. So we have almost 82% of 200 success status codes. Then 301 redirects is around 4%. There were like 5% 500 status codes which was error, and like not found is 404 is 7 almost 7%. So this clearly shows us the different status code and the corresponding MIME type which was requested. So let us go to this 200 status code and look at HTML, since that was almost 67% of the total data set. If we look at the third layer, which shows us the keywords or the keywords which we could extract from the polar data set, we see almost 8% of the total data set had in the HTML had polar keyword. Around 2.35% had Arctic as the keyword, and glacier around 1.17, and so on. So there are many other keywords. So this visualization helped us to identify the path from the request codes to the MIME type and then to the content. So the next visualization, we are showing a bar chart, a stack bar chart actually, wherein we show a ratio of the solar index, which is shown in red, to the ratio to the original file size. So as you can see, our solar index is the size of the solar index is very small as compared to the original file size. So this is the HTML. On the x-axis we have all the MIME types, and on the y-axis we have the size. So as we can see, for text HTML, the file size is almost a million, close to a million bytes for in the original data set, and in Solar it's very less. So this figure shows us the file size diversity and the ratio of Solar index to the original file index. The next visualization we used for showing the data retrieved. So in this visualization, we are showing text retrieved as well as metadata retrieved from the common crawl data set. So here we are showing the MIME types, the different MIME types on the x-axis, and the file size on the y-axis. So for example, for PDF, we can on hover we can see the parser chain hierarchy, which is like the initially default parser was called, and then PDF parser was called, and then we categorize the files uh, into different buckets. So as we can see here, almost 3,300 files, PDF files which were extracted by the PDF parser were in the range of 1000 to 5000 bytes. For HTML, we can see around 4900 files were in the file size range of 5000 to 10,000, and the parser chain hierarchy was default parser and HTML parser for HTML documents. So this was used by Tika. Similarly, we can see the metadata D3 visualization. We can see around 3300 files were 3300 files metadata was retrieved, and the file size was in the range of 500 to 1000 bytes. So we can see from this visualization, it clearly shows how the parser chain hierarchy was, and how many files, how many bytes of files were retrieved, and how many files were present in that particular file size bucket. The next visualization we are showing for the language identification in the dataset. So as you can see, almost 71% of the dataset was in English, and there were other European languages like Romanian, Hungarian, Italian, and so on. So, but the majority of the dataset was in English. The next visualization is word cloud. So we generated the word cloud from the content tags, the suite classification, the location, and the language. So as you can see, the as we saw in the previous visualization, the language identification, the majority of the documents were in English. So you can see EN, which is the English, which is the short code for English language, is almost predominant over here in the word cloud. Then other suite tags like um representation, climate, and time, etc., were also identified, and they were present in a, they had more weight as compared to other keywords. So word clouds helps us to identify the most important keywords in the total data set. Okay, the next visualization is for maximal joint agreement. So for maximal joint agreement, we are showing the three NER parsers which we used, which was Core NLP, Open NLP, and NLTK. So initially, all the documents shown here are having like maximum. So each of the Core NLP, Open NLP, and NLTK were able to find the same number of NER tags. But as we scroll down, we can see the maximum joint agreement is not same for all the three parsers. So as we can see here, Core NLP and Open NLP were able to find four of these core NER tags, but NLTK was only able to find three, and so on. So for example, we can see for the keyword meteorologist, Core NLP was able to find two, uh, but Open NLP and NLTK were able to find one. So this visualization helps us to understand the maximal joint agreement between all the three NLTK parsers which we ran on our dataset. Then the last but not the least visualization is the measurement spectrum for all the measurements which we could extract from the polar data set. So by default we are showing all the measurements on the x-axis, and on the y-axis we are showing the values for the measurement. So on hover we can see blue is for PDF, red is for XML, and yellow is for HTML. So we chose these three MIME types because measurements logically would mainly be present in HTML, XML, and PDF. So this visualization by default shows all of them. If we want to just drill down to particular HTML documents, we can just select HTML and see what were the measurements found in the HTML documents. So as we can see here, for meters, the minimum value was 1, maximum value was 7,412, and the mean was around 2,935. So thus we can see all the measurements in the HTML. Similarly, we can see for PDF. So we also categorize the measurements as per domains. So these were the three main domains which we found. And for example, polardata.ca, this domain had, for example, joules. The minimum value of joules was 151 in polardata.ca. The maximum value was 6,204, and the mean was 4186. So thus we can see the different MIME types and the measurements retrieved in polardata.ca. Similarly, if we just want to focus on one particular category or measurement type, for example length, Then we also can select length over here, and we can see all the length categorized length measurement types on the x-axis. So here it's centimeter, feet, kilometers, meters, and millimeters. Excuse. And on the y-axis we can see the values. So for length we have the meters. The maximum value is 8270, the minimum is 1, and mean is 993. So thus we can see we can choose weight and see different weight measurements. We can choose temperature and see different temperature measurements we could extract, and so on. So thus we could actually say that we actually could find a very good metadata and text data from the polar data set. And using this visualization, it helped us to understand how exactly our whatever metadata we enriched in the polar data set, how that was actually helpful to understand more about the data. And so we can say that it was really good metadata crawling, so good metadata enrichment, and we think uh, we were able to learn a lot from this assignment. So thanks for watching. Thank you.